Lesson 3.4 is another type of graphing, graphing linear equations in standard form. So standard form is essentially just another linear equation, but it looks like this. ax plus by equals c. Now I use capital letters on purpose because I don't want you to mix this b up with the b in slope-intercept form. It does not mean y-intercept. In fact, none of these letters actually mean anything really useful right now. We can do stuff with them to make them meaningful, but this is just x and y are on the same side. It's a new form of a linear equation for us to look at. So first thing to break down is just a simple idea. There's a good chance some of us are going to forget how to do this when we start graphing more and more equations, but this is a really simple thing, so try to remember. When one of the coefficients equals 0, the algebra idea here is pretty simple. And it translates nicely onto a clean-looking graph, but it ends up making our equation look different than our normal form. So I think that's why people tend to forget this over time. 0 times x is just going to be 0. 0 plus anything, well, that just doesn't change. The 0x may as well not be there. So you end up with by equals c. We would divide by b. We would just end up with y equals some number. C is going to be a number, b is going to be a number. Those divided might be a fraction, but I think for a lot of our problems, they're going to be a whole number. So here's what happens. We don't care what x is. We just care that y equals that number. This is typically what we call our y-intercept, right? It's on the y-axis. So that's the B point. But this is a horizontal line. All right? I shouldn't really be making it dashed because it is actually the line we're graphing. This is when y equals anything. X isn't in the problem. It's got a slope of 0 if we want to think of it that way. But this is a horizontal line. We know what y is supposed to equal. X is no longer in the problem, so it doesn't matter. So y can't go up or down at all, otherwise it wouldn't equal that number anymore. Vis-a-vis, it is a horizontal line. When b equals 0, it does the exact opposite thing. The y part's going to cancel out, and we're left with x equals c over a. Again, the important idea there is that it's just x equals a number. The c over a thing is just like a more college, higher level math way of saying, like, this is two numbers divided by each other. Well, when you divide two numbers, you get a new number. Sometimes it's a fraction, sometimes it's not. But now we would have an x-intercept. All right. Same logic as last time, but this time flipped in terms of x. This is a vertical line. X has to be whatever number this is. Again, I just put the line in any old spot just to demonstrate what it would look like. X is whatever number we tell it to be and can't change, so it can't go left or right at all. Y is no longer in the problem, which means it can go up and down as much as we want. This is a vertical line. So you get your perfectly horizontal lines and your perfectly vertical lines when one of the two variables cancels out. This, or at least the idea of this, is kind of how we're going to graph these as, lines with slopes. We don't actually have to find the slope. We can find the y and x intercept using this method, and then just connect the 2 points. Here's a problem that asks us to actually graph this using numbers. So what we're going to do is we're going to find the x-intercept by making y equal 0. This is one of the easiest darn things we can do in math, I swear. This is when we're able to plug 0 in for a variable, that term's just going to be gone. Same logic as earlier, 4 times 0 is 0, and adding 0 to anything just doesn't change it. So we basically just have 3x equals 12. And that's, about as simple as an algebra solving equation can get. X equals 4, that's an ordered pair. It might not look like it when you just see this x equal 4. Where's the y value? Well, remember, we plugged in 0. So this is x is 4, y is 0, 4 comma 0. So let's fill in our graph over here. There's 4 comma 0. Now let's find the y-intercept. To find the y-intercept, we want it on the y-axis, which means x equals 0, not going left or right at all. We want to stay on that middle line. The 3 times 0 is just gone. Dividing by 4 is going to get us y equals 3. Same thing as last time. Knowing what we plugged in to start with gives us our other value. X is 0 this time, 0 comma 3. Let's plot that point. Now that we have 2 points, draw a line through it, and we have successfully used the intercepts to graph. Here's the modeling problem from the notes. Now the actual question in the notes gives us the equation, but I want to briefly talk about what's happening here. We have a number we need to meet, a number we need to match essentially. So that's the number we're going to equal. At the end, we have to be able to seat 180 people. Now the choices we have get paired with variables. We can choose different numbers of small and large tables. Small numbers seat 6, large tables seat 10, and it's some mix of those have to add up to 180. So 6 small tables plus 10 per large table. So this is 6 times the number of small tables, 10 times the number of large tables. Well, let's get rid of the s and the l and make it x and y so that it's clear which axes we're using. Technically, in a problem like this, it doesn't matter which one's x and which one's y. Now, which one of these is the independent variable? Well, this is part of the reason standard form equations exist, is you don't always have an independent variable. Sometimes it's just a relationship that depends on your two different types of information, I guess. So we're supposed to graph this, and graphing it's actually relatively easy. If we only went with small tables, how many would we need? 30 small tables. 30 times 6 is 180. If we only went with large tables, what would we need? 18 of them. 10 times 18 is 180. All right, so those are actually two possible solutions. 30 comma 0, where we buy 0 large tables or rent them, and 0 comma 18. Now, there's a simple way to figure this out and a way that uses the graph. The way that uses the graph is if we actually plot these points, we can try to find other areas where the points connect. The other way we can do this is find like a relationship. All right, so we need to find the least common multiple of these two numbers, something that 6 multiplies up into and something that 10 multiplies up into. All right, the trade point, the smallest one we can go with is 30. That either takes 5 small or 3 large. So this ends up being our trade number. If I lose 5 small tables, I need 3 large to make up for it. 25 small and 3 large. Well, this is going to be 150 plus 30. We still have that exact 180 number. We traded 5 small tables for 3 large tables. Let's do it again. 20 and 6. Well, now it's 120 and 60. We can work from the other way too. Trade 3 large tables, go down to 15 for 5 small tables. Now I've got 150 plus 30. Okay, so we can find way more than 4 possible solutions. This is the numeric way to do it. We can do it just looking at the graph as well. All right, so that's pretty much all there is to dive into about standard form right now.